Hi folks, welcome back to 6.2 Disc and Washer Method Practice. In this video, we'll take a look at question number 5. Question number 5 says, find the volume of the solid of revolution generated by rotating the region bounded by f of x equals x cubed, y equals 1, and y equals 8 around the y-axis. Okay, so let's start with our graph. The graph of f of x equals x cubed. If I plug in some points, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. All right, and let's go ahead and connect those. So I have part of my cubic graph. Now let's see what our other bounds are. So y equals 1 is a graph that looks like this. It's just a horizontal line at y equals 1. And the purple line is going to be a line at y equals 8. So this is y equals 8. And that is the region that we are going to be rotating around this line. So this is our axis of revolution. And the equation for this one is not going to be y equals 0, but x equals 0. Okay, so now when we revolve, we know that we're going to have the area of a circle, because the cross sections will be circles, and we're going to have pi r squared. So let's draw in where our radii are. Well, since I'm revolving it around the y-axis, my reflection drawing should look something like this. And so my radii are going to be this way, and they are perpendicular to the y-axis. So let's set up our integral. Volume equals, the integral of the area, and since we're stacking the radii up the y-axis, it's going to be dy. Okay, so let's come up with our bounds. The bounds go from a y value of 1 to a y value of 8. Pi times my radius, which I'm going to have to use this for. Okay, so x cubed squared dy. Now this, unfortunately, is not going to work for us because this is in x's, whereas everything else is in y's. So what we need to do is rename our function. So y equals x cubed is the same as x equals the cube root of y, or we could say that is y to the 1/3. Now y to the 1/3 is what I'm going to put in here because it's another name for the same curve, but it has the letters I need to match all the other letters. So pi times the integral from 1 to 8 of y to the 1/3 squared dy. And when we simplify that, that's going to be pi, the integral from 1 to 8 of y to the 2/3 dy. And now we're ready to integrate. So y to the 5/3, and the reciprocal of 5/3 is 3/5. I'm going to plug in 8, and I'm going to plug in 1. Now this is the kind of work I expect that you are able to do without a calculator, okay? So let's go through this step by step. Pi 3 pi over 5 times 8 to the 5/3 minus 3 pi over 5 times 1 to the 5/3. This is going to give us 3 pi over 5, the cube root of 8 to the 5th, okay, minus 3 pi over 5 times, oops, and this one is easy because 1 to any power is 1. All right. Well, let's take each one of these 8s at one at a time. So the cube root of 8 is 2, the cube root of this 8 is 2, the cube root of all the 8s is 2. So I really end up with 3 pi over 5 times 2 to the 5th minus 3 pi over 5. Now this is going to give me 2 to the 5th is 32. So 96 pi over 5 minus 3 pi over 5, which will give me 93 pi over 5. All right, so let's zoom back out. But we should end up with a final answer of a volume of 93 pi over 5 for question number 5. All right, that's it for this video. Come on back for video number 6.